So for d's of the form where dy dx is equal to a function in terms of y as opposed to in terms of x, what we're looking to do is just make use of their reciprocal properties. So we want to take the reciprocal of both sides, so we get dx dy equals 1 on f of y, and then integrate both sides with respect to y. Okay, I obviously can't integrate if dy dx equals 6y. I can't integrate both sides with respect to here because I've got a function in y and I'm trying to integrate it with respect to x. So it's not right. You've got to then find a function y equals. So instead, we take the reciprocal and we integrate both sides with respect to y and then transpose the equation to get y equals. So if we have a look down here, we can sort of see that our dy dx is equal to 4y, so my function is in terms of y as opposed to x. So if I reciprocal both sides, I get dx dy equals 1 on 4y. So integrate both sides with respect to y instead, and take the quarter out as a constant. I get the integral of a quarter at the front of 1 on y dy, which is obviously a log function. And I get my plus c here. So what's worth noting is if I take my c across, my constant of integration, multiply by the 4 over, and then I've got log base c. So everything get raised to the power. So I've got e to the power of 4x minus c. Now that e to the 4x minus c could be considered as e to the 4x times e to the negative 4c. Yeah, same base, add the powers. And this expression here is just a constant. Okay, and that's what we're looking for. We're looking for the constant and we need initial conditions. So we represent that with another constant. And typically we use the big capital letter A. So that's what we've done here. So that e to the minus 4c, I've just represented as, we should have an equal sign there. So in reality, y is equal to some a e to the 4x. So there's my constant of integration incorporated in there. And then we get an initial condition of some sort to help solve for a. And you can see from our CAS, we get C26, which is just a constant e to the 4x. All right, so once you take the reciprocal of both sides, our integration process follows. If we continue that through, same sort of thing, dy dx is equal to 9 minus y squared, so the right-hand side is in terms of y instead of x. Take reciprocals, and we get our sine inverse function. So again, whether you try to find your constant here or a bit later, it's up to you. I always look to try and find it at the interim point, and then if it gets too messy, maybe look for it at the end. But in this case, we quickly see that c value is negative pi on 2, transpose everything, and our function for all intention purposes, we get y on 3 equals sine of that angle, so y equals 3 sine of that angle. X plus pi on 2, sine of x plus pi on 2 is the same as cos x, which is why our CAS gives us a 3 cos x term instead of instead of sine x plus pi on 2. Equivalent expressions, and if we were doing an assessment, we'd probably leave it as sine of x plus pi on 2. Finally, again, I've got a function in terms of y here, so I'm going to have to take a reciprocal, integrate both sides, and from in here, hopefully we see we have partial fractions, so we split it up, repeating linear factors, do our cross multiplication, we get our a is 1 and b is negative 1. All right, substitute that into our integral, and so then we get natural log of y minus natural log of y plus 2 plus some constant c. I think we need to get into the habit of combining our y functions into one term, all right, and then it makes solving and transposing a lot easier. All right, so again, if we transpose and solve here, we'll get c is negative natural log 2, and then again, let's build it into the function. So when we subtract logs of the same base, we divide. So that's where that 2 comes from down there. All right. Again, we take the exponential of both sides. I'm going to multiply this 2y across, which is what we've done here. Expand it in group-like terms. So get the y values together, or the y terms together, So I can take y out as a common factor, and then I can divide the term back over, all right? Which hopefully is what we've got over here somewhere, all right? So again, step one, if we see that our right-hand side typically is in terms of the y variable, well, we need to integrate with respect to y, and that often involves taking the reciprocal.